Welcome back to Lahari tutorial. So in a previous video I have explained the formation of a complex based on a valence bond theory. ಶ್ವೇತಾ ಅವರು ಈ ಎಕ್ಸಾಂಪಲ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿರಿ ಅಂತ ಕಮೆಂಟ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ನಾ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋದಲ್ಲಿ ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ವಿ ಬಿ ಟಿನ ಬೇರೆ ಎಕ್ಸಾಂಪಲ್ ತೊಗೊಂಡು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಇಲ್ಲಿ ಲೆಟ್ us explain the question with this example, hexamine cobalt 3 ion. So here on the basis of valence bond theory we have to explain geometry, hybridization and magnetic property of this complex. So for explaining this one, first we must know the central metal. Okay, here the central metal is cobalt. So the atomic number of cobalt is 27. Okay, next the electronic configuration of cobalt, that is here the organ, it is 18. The atomic number of organ is 18, 3d7 4s2. okay, then 4p. okay, let us take a orbitals. We have to consider these 3d7 4s2 and 4p. okay, first for a cobalt ion, that is 27, already we know the configuration. okay, 3d7 4s2. in the d orbital there are 7 electrons and in s orbital there are 2 electrons and the 4p is empty. So here in this complex the cobalt ion is in +3 oxidation state. You can see here the complex charge is +3. okay, so here the ligand is neutral, so here it is 0 oxidation state. Then the oxidation state of central metal will be +3. okay, so here in this complex the cobalt ion is in +3 oxidation state, so it lost 2 electrons from s orbital and 1 electron from d orbital. okay, here 2 electrons from s orbital and see the 1 electron from d orbital. okay, you can see here. So this ion lost 3 electrons. okay, 2 from s orbital and 1 from d orbital. okay, next, due to the strong ligand, that is the ammonia is one of a strong ligand, so it is approaching towards central metal ion, so that the rearrangement of electrons takes place against the Hund's rule. okay, so here these electrons shift towards here because the strong ligand, due to the strong ligand the electrons are rearranging against the Hund's rule. So we can see here. Now the available orbitals for hybridization, that is 2d orbital, 1s orbital and 3p orbitals. okay, here 2d orbital, 1s orbital and 3p orbitals undergo hybridization to form 6d2sp3 hybridized orbitals of cobalt, the pointing towards the 6 corners of an octahedral. okay, the 6 orbitals, 2d orbitals, 1s and 3p orbitals, that is hybrid orbitals. Here these 6 hybridized orbitals of cobalt ion overlap with the orbitals of a 6 ammonia ligands and 6 pairs of electrons donated by a 6 ammonia ligands to form a 6 coordinate bond. okay, so here there are 6 hybridized orbitals of cobalt ion which overlap with the orbitals of a 6 ammonia ligands. okay, then the 6 pairs of electrons are donated by the 6 ammonia ligand. okay, so there is a formation of a bond. How many bonds? 6 coordinate bonds. okay, thus the complex has a octahedral geometry and is diamagnetic due to the absence of unpaired electrons. okay, see here after rearrangement, see we have to consider magnetic property after rearrangement of electrons. okay, is there any unpaired electrons? No. So it is a diamagnetic in character. Okay. So here we know that there are 6 ammonia, means the coordination number is 6. So the geometry will be octahedral geometry, and the magnetic property is diamagnetic because due to the absence of unpaired electrons. Okay, in the formation of this complex, the inner d orbital, that is 3d, is used in a hybridization, so that the complex is called an inner orbital complex or low spin complex, or it is also called spin paired complex. Okay, so here the inner d orbital is n-1 d orbital, so it is called inner d orbital, and nd is called a outer orbital. Here we are using a n-1 d orbital, that is 3d, so that it is called inner d orbital, and inner orbital complex, and also it is called low spin complex or spin pair complex. Okay, so this is about the formation of complex based on a VBT. Here the geometry is octahedral, the magnetic property is diamagnetic, the hybridization is d2sp3, yes, d2sp3 hybrid orbitals. Okay, ವಿಡಿಯೋ ಇಷ್ಟ ಆಗಿದ್ರೆ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಆ್ಯಂಡ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಥ್ಯಾಂಕ್ ಯು.